So this is the plus one problem. You are given a large integer represented as an integer array digits, where each digits array is the ith digit of the integer. The digits are ordered from most significant to least significant in the left to right order. The large integer does not contain any leading zeros. The large integer does not contain any leading zeros. Okay, increment the large integer by 1 and return the resulting array. So like the first two examples which I see here are would be easy to do, but when we look at the third example, this is going to be a tricky uh, case for the output we would be looking for. So we would have to treat this as a binary addition when we do. So let us visualize this solution. So first of all, let's look at the question. This is going to be our sample input and output. Let's consider this. So this is our example output right here, and let's go through like uh, two steps of two different approaches to this solution. First, first solution being we look at the nth, like the last integer, last index. We look at the nth index and figure out if the last index is 9. Last index is 9, so we'll add 0 and follow the binary addition rule at going from right to left. So that would be an approach which would be a bit efficient. So the second approach would be that we convert this integer array into an integer output, basically resulting in 1, 2 and 3, and we basically add one to it and convert it back to an integer array of 1, 2, 1, 2 and 4. So this is the second approach. I would be first trying out with the second approach and seeing like what results do we get from this. So let me start coding out the second solution. So let's write this out. Let's have a variable v1, which is equal to convert the integer array to an integer. We'll do percent digits. The integer array is digits dot join to 10. When we have this, we have basically converted our integer array to a single integer, and we have to add the add 1 to the number. So here we do v1 is equal to v1 plus 1. Then now we have the output. So we'll actually use another output. Actually we'll use, no, v1's fine, we can use that. So const new variable v1 is equal to our initial variable which we took, v1 dot to string to string. Then we have to split it back into its individual components. We use the split function for that to basically split the integer back into its component, and we map out the variable which we want to then basically get back. So this should probably be the function, and let us see how we can implement this here. Let's see. So this, so probably this is what we return. So we return nv1. So let's have a run at it. If we get any errors, we'll see. So we have a nice little error here. What is this? Invalid unexpected token. There should not be an issue, I feel. Let's do the number of method, I guess. Let's try a number if we get a result out of it. Unexpected token. Invalid unexpected. So yeah, I feel I might have found the issue. This is what you get when you type in Google Docs and have your commas, apostrophes differently. So hope this is the only issue that needs to be resolved for the token. Yeah, we have a constant variable, so we can't ascend. As I previously said, this should come as an issue afterwards, but let's resolve this and have it sorted. And v2 is our variable, so nv1 is dot, we should be converting v2 to this and map, well, basically v2 again. So dot to string, okay, that's a typo. Dot to string. Well, I have to practice a lot on writing on Google Docs and not have typos again. Number 124 is not a function. So wait, this should not be here. It should be a number which we should be returning. So we are mapping a number. So that's the issue. Should probably get an output here. Yes, we do indeed get an output from this passing all test cases, but this is a very lazy man solution for actually doing this. If I had the knowledge, I would be discussing the second part of it. So this is the wrong answer as I expected. So this is the one-liner solution which I found which got accepted, and it almost follows the same principle what I have done here. So let's try to improvise from this person and let's see if we get something from this. Okay, let's actually just you know try the actual one liner. Let's try the one liner. I feel my solution has loss of, like, there's data loss. I feel yeah, we should actually I feel this works, but let's see if we can make this one work by having, instead of numbers, we have big int, and we try to run this. Okay, let's okay, this works. Let's, like, submitting the result, how we get to a solution. Okay, we get to the same solution. So I felt this was a logic, but I didn't knew that we'd be facing data loss. I guess the loss of the actual integer. If there's a, I had hoped for the edge case where we would have a large enough integer array that we won't be able to fit, and I feel that test, like that edge case comes into play here, which I had intended, but I I actually, like, it's the first time I'm using big int, but I hadn't used it much. So I guess that's the solution.